In this video, we're going to be talking about linear function rules. What are those? Well, not too difficult to explain. Any equation that names a linear function is a linear function rule. So the graph of a linear function, as you know, is always a straight line. And linear function rules, they tend to look different from nonlinear function rules. And I've got some examples here. So linear function rules, linear function graphs, linear function equations, however it's going to stick in your head. And the letters don't matter so much, but they basically, in terms of variables, follow this sort of a format where you have something like y equals mx plus b. That's something you're very familiar with. That's always going to be a linear function. D equals 3t. That will always give you a linear function, something where you've got a variable on one side and then a coefficient multiplied by another variable. That's going to give you a linear function. Something like this third example where you have one variable equals another variable and it's divided by 2, or whatever factor it's divided by, dividing it consistently each time. Nonlinear function rules don't make straight lines when you graph them, and they are things like this. Anything with an absolute value, y equals the absolute value of x, that would be nonlinear. Y equals anything to an exponent, to a power, is nonlinear. And any time that you have something where you have a variable for a denominator, that's going to also be nonlinear. All right, I'm going to get set up to take a look at some nonlinear function problems, some linear function rules, and we'll go from there. Okay, in this problem I'm asked to give you the function rule from the graph. In other words, what I'm trying to do here is I'm trying to use this form, y equals mx plus b, and I know there's a b because I can see this line does in fact cross the y-intercept, and let's start with that. Where does it cross the y-intercept? It crosses it here. That's -2. This is -3. So I know that b equals -3, and my next task is to find the slope. So let's start by counting rise over run, shall we? I'm going to count to here, starting here. So I'm going to go up 1, I'm going to go up 1, I'm going to go up 2, and I'm going to go over 1, 2. And I can see if that works again. I'm going to go up 1, going to go over 2, 1, 2. All right. Well, it's clear to me that the slope of this line would be 1. So m, of course, equals 1. And writing the equation, or the function rule here, would be y equals x minus 3. And that would be my function rule. All right. I'm going to pause for another moment and move on to another problem. In this problem, I'm given a set of points. And those points, as you can see, the ordered pairs are -1, -1, 0, 0, and 1, 1. And they're on a graph of y equals x3, so that x to the third power. So that would be what the graph would look like, y equals x to the third power. And your friend, and of course, you know, this can't be good because how I feel about friendship, your friend says that since you can draw a straight line through the 3 points, which you can, of course, if you put these on a graph, then y equals x to the third power is a linear function. Do you agree? Why or why not? Well, the answer is no, I don't agree, and I don't agree because I took this out another couple of steps, and you can see why I don't agree. It is true that -1 to the third power would be -1, and 0 to the third power would be 0, and 1 to the third power would be 1. But if I use 2 for an input for x, my output is now 8. If I use 3 for an input for x, my output is now 27. So clearly, this demonstrates that this is not a linear function and that my friend should have put a little more effort into his mathematics. All right, let's take a look at one more problem. And for our final example, we're given this, that Matt is 3.5 years older than Sam. What function rule describes Matt's age during any given year? Okay, so I have to use that information to write a function rule, and here is my function rule. I'm going to say let S, I'm sorry, that's an S, not a 5. My apologies for my poor penmanship. let S equal Sam's age and let M equal Matt's age. Well, I know that Matt is equal to Sam's age plus 3.5. And yes, you could have used a decimal. And that would be, these would be several examples of defining linear functions from word problems, ordered pairs, and graphs.